All right, so now what we're going to do is go to this, and we're going to continue just a little bit with section, we'll just call it R1 again. This is kind of like R1 part 2, I guess, if you want to call it that. All right, so let's set up this so I can, let's do a different color. Let's do orange, see what that looks like. What's that look like? Can you read that all right? All right. Okay, so let me get my notes out and let's see where we left off. And again, this stuff is really pretty simple, but again, it's just the beginning. Hopefully you think it's simple. And let's see, we finished up with the 0. Remember we said if anything times, a number times 0 is always 0. All right, so we talked about that. But we are going to, that's a very simple concept, but it's going to be something that, and I said this yesterday, it's going to be something that, how should I say this? That we're going to use the concept, we're going to use it in a lot more of a difficult situation, okay? A lot more complicated, I should say. Not difficult, but a lot more complicated situation with that 0 thing. So we're going to set a lot of things equal to 0. Do you remember in Algebra 2 doing that kind of stuff? You set a lot of things equal to 0, then you had to solve for x and that kind of thing. So that's the kind of stuff we'll do eventually. But let's just finish up section R1, the review 1, and then we'll go into R2, the review section 2. All right, so the first one is, let's see, it says arithmetic of quotients. All right, so we're going to add and subtract fractions. Because remember yesterday we talked about a quotient was a fraction, or a division, I'm sorry, which is a fraction. Let me just do it, okay? So it's a over b plus c over d. That's a d right there, supposed to be. Sorry about that. All right, so if you want to add these fractions together, okay, what do we have to do? When you add fractions, what's the one thing that your math teacher back in 4th or 5th grade always told you to do? Find a what? Common denominator. That's right. All right, so one way to find a common denominator, you could always find a common denominator. It's not necessarily the smallest one, but you could always find a common denominator just by multiplying these two together, okay? Because that means if you multiply them together, that means b will divide into it, and that means d will divide into it because we multiplied them together. All right, so we could do that. So what I do, this is how I do it. Different teachers do it different ways, I guess, but I do it like this. I'm just multiply them together, BD. Now, let's change colors a little bit here so we can mix it up. Now, you have to ask yourself, now this is super general. This is very, very general. There's no real numbers in it or anything. There's just variables in it, but this is basically how you add fractions. What you do is you ask yourself, how did you get from B to BD? What did you do? What did you multiply B by in order to get BD? What was it? A D, right. So that means if you multiplied by this by D, what do you have to do? Multiply the top by D. Now, is that the same rule where if you do something to one side, you do it to the other side? It's not the same rule, okay? It's similar to it. It sounds similar to it, but it's really not. Because what we're doing is we're multiplying the denominator by a number and we're multiplying the numerator by the same exact number. So that means you have a number over itself. What's anything divided by itself? It's 1. So really, basically, what did we just do to this fraction right here? We just multiplied by what? 1. Does multiplying by 1 change anything? No, not at all, okay? So we'll do a little bit more. So now you ask yourself, what did you do to this? What did you do to D to get BD? You multiplied it by B. So if you multiply that by B, you multiply the top by B, not because if you do it to one side, you do it to the other. That's not the rule. The rule is you're just making this a 1. So if I multiply by a 1, I didn't change the value of it at all. All right? Does that make any sense? Okay. So now what do we get? We got BD is already right here. It's already that common denominator. So now we have AD, and then you have CB, or I like to kind of put it in alphabetical order, BC. Doesn't make any difference. It would be perfectly fine if you put CB. Now remember, these are going to be like real numbers, okay, at first, on the easy stuff. Eventually, we're going to add some fractions that are way more complicated than this. But this is our basic idea. This is our basic concept in order to add fractions. We're eventually going to add some fractions that have tons and tons of variables and numbers and exponents and all kinds of crazy stuff, all right? And we're going to have to add them together. But this is about as basic as it gets, as general as it gets. So that's how you add fractions, okay? Let's multiply fractions. So basically what we're doing is we're just dealing with fractions, and we've figured out how to add fractions. So now subtraction would be the same thing, okay? The rules for subtraction are the same. So now let's do multiplication. Let's multiply fractions, which is actually easier. You know, when you're a kid and you learn how to add, that was easy. And then when they taught you how to multiply, I don't know about you, but I had a very traumatic experience when it came to learning my multiplication tables. I told you yesterday that I lived in Australia. Well, when I left America, I was in second grade. I was 8 years old. Okay, I left in second grade. But when I went to Australia, they were ahead of us, and so I had to go into third grade, and they were considerably further ahead than that I was in America. And we hadn't learned our times tables yet in second grade. I don't know if they do nowadays. I don't know when they learn them nowadays, or if they even learn them. I heard stories on the news that people don't even learn their times tables anymore. I don't know. But anyway, when I went to Australia, I didn't know my times tables, but everybody else in my class did. Well, my dad was a teacher. That's the whole reason I was in Australia, because my dad got his teaching fellowship to go over there and teach for 2 years. And so every day after school, he would just drill me on my multiplication tables. I remember one time I would come out, I'd be in the bedroom, I'd try to learn my multiplication tables, I'd come out and he would quiz me. And he would say 3 times 5. I'm like, 15. Okay, 7 times 8. And I took too long. He says, get back in there and learn them. That's too slow. And so I'd have to get back in my room. I was bawling my eyes out. So that was my introduction to math, okay? It's a miracle that I'm a math teacher today. But anyway, multiplication tables were tough for me because I had to learn them like really quick because everybody else already knew how to do them. But now multiplication is pretty easy. All right, well, multiplication of fractions is even easier than addition. Addition and subtraction of fractions is the hardest thing to do. Multiplication and division are pretty easy to do considering. So if you multiply fractions together, it's supposed to be a dot. If you multiply fractions together, you just multiply the bottom, you multiply the top. Okay, you multiply the denominators, multiply the numerators. Now, if there's something that can like cancel out, remember we talked about canceling out yesterday? If there's something that can divide out from the top and the bottom, we would do that first. Now, right here, they're all different, so my glasses are all fogging up. Don't want mask. You don't mind getting a little COVID, do you? If I just put this under my nose. All right, so you multiply the bottom and the top. So the bottom is BD, and the top is AC, and that's all there is to it. Super, super easy. All right. Of course, it's going to get way more complicated than that, but for right now, that's it. Yes, sir. Say that again. I've never said that exactly thing, but that's basically what it is. I've never used that phrase, but yep, you can use that. Yes, sir. Weren't you out already? Go ahead. Try to go before you come in here so you don't have to leave. All right, let's do division. Now, different teachers have different little ways of saying this. Cameron, what'd you say? Keep, change, and flip. Okay, I understand what you're saying. That's pretty good. Keep, change, and flip. So what we're going to do, this is division. You actually got several divisions going on here. You got A divided by B, you got C divided by D, and then you got this whole thing on top. See this whole fraction on top being divided by that whole fraction on the bottom. And that's this thing right here. That little bar right there means division. Okay, what I usually say is this. I usually say division is the same thing as multiplying by the, anybody know? Reciprocal. Reciprocal. Did I spell that right? Okay. It's multiplying by the reciprocal, or you just multiply by the inverse. Some people say that. Reciprocal and inverse are kind of the same thing, okay? So basically, you do this. You just take the top, and if you divide it by the bottom, you keep the top the same. Instead of dividing with fractions, what do? We multiply by the reciprocal, or you just flip it, okay? So you just flip it, and that's D over C. And now what we did is we took a division problem and turned it into a multiplication problem. All right, and now we already know how to multiply. So on this one, what is it? It's AD over BC, and that's our answer for that. Pretty simple, right? Yeah. All right. Let's change colors. Let's do a couple examples with some real numbers. All right, let's start off really easy. Again, I don't like saying this all the time, but I'm going to. This is just elementary school stuff, all right? So let's just do it pretty quick. So what can we do to find a common denominator? You could just multiply them together, couldn't you? Or you find a number that both of the numbers divide into evenly, right? You ever hear that? So you find a number that they both divide into evenly, and the only one, or the smallest one, I should say, is 6. So you just multiply them together. 3 times 2 is 6. Now, I'll write this out just to show you the steps. So here's the question. Now, we don't have A, B, C, D anymore. We have actual real numbers. So what do? We take 3 times what is 6? What do we multiply 3 by to get 6? Multiply by 2. All right, and then you do the same thing to the top. Why do we do that? Because you're multiplying by a 1. We didn't change the value of it at all, did we? That's all we're doing is multiplying by 1. Okay, what'd you do to this? What'd you do to 2 to get to 6? Multiplied it by what? 3. So you do the same thing to the top so that we have a 1 here being multiplied. All right, let's go back to green. And so now let's see what we get. We get 2 times 2, gives us a 4, and we get 5 times 3, which gives us a 15. You add those together, and that's 19 over 6. We just keep it like that, and you're good to go. It doesn't reduce. Okay, you should always reduce your fractions. Now, some people think that reducing a fraction is changing. Let me ask you this first of all. Again, we're going way back in time. What is it when you have a larger number in the numerator than you have in the denominator? So the bigger number's on top. If you have a bigger number on top, it's an improper fraction. Some teachers really harp on changing an improper fraction to a mixed number. Okay, you could do that if you wanted to, but you don't have to unless I tell you have to. Everybody understand that? So as long as it's reduced, as long as there's no number that divides evenly into both of these, then you can keep it improper. I'm perfectly fine with that. I know some teachers have a problem with that. There's some people with their heads down. I know the lights are out, but I need your head up. So I'll call your name in a second if your head's not up. So a friend, maybe you might want to tap somebody because I'll call you out. All right, so I need your head up. I need you paying attention. I know this stuff is old news, and but you got to watch what's going on. Okay, let's do another one, and we're almost done. Well, a couple more, and we're almost done. There's a fraction one in here. I'm not even going to do the fraction one. Let's do a multiplication one. So let's go 8 divided by 3, or 8 over 3 times, what is that, 15 over 4. I'm just doing the examples right in the book, okay? Now, if you take a look at this, you could just multiply straight across the top, multiply straight across the bottom, and then you can simplify. But I would simplify right in here first. It's going to be a lot easier. So what we're going to do is we're going to look at the 8 and look at the numbers on the bottom. Is there anything divides evenly into something on the bottom and something on the top? Yeah, the 4 and the 8, right? So 4 goes into, we'll go back to the pink here. Okay, so 4 goes into 4 once and 4 goes into 8 how many times? Okay, twice. So 4 goes into 4 once, into 8 twice. Everybody got that? Right? You've done this a million times before, haven't you, in your math career? Yep. Let's look at this. 3 and 15. Anything go into 3 and 15? 5 doesn't go into 3. Okay, 3 goes into 3 once, and 3 goes into 15, what? 5 times. Okay, or divides into it. I say goes into it. That's probably not the best way to say it, but it divides evenly into it. So what do we get on top? Now we can multiply. There's nothing else that cancels out. We got 2 times 5 is 10. 1 times 1 is 1. Do we want to keep it like that? No, we keep it 10, and that's it. Should have gone back to green to keep my color scheme going, but that's okay. All right, let's do a division one, and then We'll talk about least common multiple in a second, and then we're finish that lesson officially. So let's go back to green. So 3/5 divided by, is that a 9? Yep, 7/9. Okay, so here it is. There's your fraction. You could have written it like this. Like they could have done this by 7/9. Isn't that the exact same thing? Yeah, absolutely. Okay, so it's the same thing. Oh, by the way, you ever wonder, probably not, but you ever wonder about the division sign? Okay, this division sign, so you have a dot right here, and then a bar, and then a dot. That's our division sign. You know where they got this from? They got this from this. This represents the top dot. This represents the bottom dot, and this is your little fraction thing right here. Did you ever know that? Isn't that cool? All right, so that's basically where the division sign thing comes from. Learned something new today, didn't you? All right, so let's do this. So what do we do? Cameron, what'd you say it was again? I can't remember. So you keep the top one, right? And then you change the sign, right, from division to multiplication, and then you flip the bottom one, right? That's supposed to be a 9. That's a weird-looking 9. We'll try to make it look better. So now, but I like to say we multiply by the reciprocal, all right? So instead of division, multiplying by the reciprocal, so we flip that one, so it's 9/7. There we go. Now, does 5 go anything up here? Does 3 go anything down here? 7, 9, anything? No, nothing cancels out. So our only option is to just multiply straight across. So that would be 27, and that would be 35. Nothing goes into anything there, and that's our answer. And that's how you do it. By the way, when you do your homework, I just mentioned this briefly on your way out yesterday, but this is how you would do this. So let's say this was like number 4. Okay, this is how you would do your homework. You would write number 4. You'd write the problem down. You'd show your steps. Okay, show your work. It's a big deal for me. Okay, showing your work is a huge, huge deal for me. I don't want you just to put number 4, 27/35. Okay. I will not accept that, all right? You got to write the problem out, show your work, and then write the answer and circle your answer. Everybody got that? All right, I should have mentioned that a little bit more detail yesterday, and most math teachers are kind of like that as well. Let's do one more thing. Let's do least common multiple. Let's see, what time do we get out of here? 50. Okay, we're good on time. Least common multiple. Let me write that out. Least common multiple. Or we just shorten it, the LCM. Okay? I'm going to show you, I don't know if your teachers before me have shown you this, but I'm going to show you a way to find the least common multiple. That's, I don't know, it's kind of, I guess it's easier, or it's, I don't know, it's just a nice way to do it. So I'm going to give you 2 numbers, 15 and 12. So what we want to do, the least common multiple means it's the smallest number that 15 and 12 both divide into. Did you hear what I said? So it's the smallest number that 15 and 12 divide into. So I could like multiply 15 by 12. I don't even know what that is. What's 15 times 12? Somebody do that real quick. Anybody got a calculator on? What's 15 times 12? Nobody's doing it? I don't see anybody moving. I should be able to do it in my head. Sorry. What is it? 180? Is that it? Okay. It's not like I don't trust you, but I'm going to do it anyway. Very good. Yeah, it's 180. So 180 is a common multiple, okay? Because 15 divides into 180 12 times. 12 divides into 180 15 times, okay? But it's not the what? Least common multiple, all right? Let me show you a nice, easy way. I learned this from another book. I don't know. Some teachers may have taught this, may have not. I don't know. I'm just going to do it anyway. So what I'm going to do is I'm going to break 15 down into the product of primes. I'm going to break it down into the smallest things that multiply to be 15. So really, it's pretty easy. What times what is 15? 3 times 5, right? You've done this before, haven't you? Little factor trees. Remember factor trees and all that? Yep. That's what we're going to do right here. But we're going to break it down. We're going to keep factoring as far as we can go. All right? So what about 12? Well, 4 times 3, or you can go 6 times 2, right? Either way. But is this down to the prime numbers? No, 4 is not prime. So what do? We break that down into 2 times 2, and then you drop that straight down. You remember that? The good old days of elementary math, yeah, or pre-algebra or whatever it is? Okay. So what we have is we've got these set of numbers, we've got these set of numbers. Now, in order to find the least common multiple, and you're probably thinking, why would you do this with numbers like this? I could probably come up with something a little bit easier. But when you have big, gigantic numbers, or if you have a lot of variables with exponents and all that kind of stuff, negative exponents, okay, this is going to help you. This method will help you out finding the least common multiple when it gets a lot more complicated, okay? This particular set of numbers, it wasn't that hard, but here's what we're going to do. So let's change color real quick. So what I'm going to do is I'm going to look to see all the numbers that show up in both places. And I'm just going to start writing them down. But if it shows up more than once, I'm going to take the one that shows up the most number of times. I know I said that quick. But I'm going to take each number that shows up in each one. If a number shows up more times under 1 than the other, I'm going to take the one that shows up the most number of times. So what do we got? We got 2's. How many times does the 2 show up? Twice. So I'm going to write 2 times 2. So I'm done with that. Now look, I got a 3 here and a 3 here. If they show up the same number of times, I just take how many times it shows up. So how many times does it show up in either place? Just once, right? So I put a 3 right there. What other number shows up? The 5. Okay, it only shows up one time, so I just put a 5 right there. If I multiply all those together, I automatically get my least common multiple. You ever see that before? Okay, I think it's a cool way to do it. When we get to the point where it gets more complicated, maybe we'll take some time and do that. But right now, we'll just leave it like this. So we can do this in our head. 2 times 2 is what? 4 times 3 is what? 12. What's 12 times 5? 60. And that's your least common multiple. Okay? So 15 divides evenly into 60. 12 divides evenly into 60. And that's the smallest number. 60 is the smallest number that 15 and 12 both divide into evenly. Okay, that's your least common multiple. Make sense? Why in the world do we want to find the least common multiple? Just because it's a math thing to do? No, because it helps you find your common denominator. Okay, when you find your common denominator, that's what this is. The least common multiple is your common denominator. Okay, so let's do a real quick example with that, and then we'll be finished with review section 1. So let's do... Well, they use the same numbers, and that's okay. I'll just show you with the same numbers. So here's an example. You might have 8 over 15 plus 5 over 12. And you need to add those fractions together, okay? So what do? Find a common denominator. What is the common denominator? It's the least common multiple, isn't it? All right? So you go through the whole thing. I already did it once. I don't have to go through it again, all right? So I already did this. I'm like, oh, 60 is my common denominator. That's my least common multiple, okay? That's my common denominator. It's my smallest one. And now I can go ahead and figure out what my numerators are supposed to be. So what do I multiply 15 by in order to get 60? If you look over here, there's your 15. What would I multiply it by in order to get 60? A 4. So I multiplied it by 4. So what do I do to the top? Multiply that by 4. What do I multiply 12 by in order to get 60? I multiply it by a 5. So I multiply that by a 5. Everybody with me so far? Okay. So now I just figure out what my numerator is. It's 8 times 4, which is what? 32. And then 5 times 5, which is 25. Okay. And then I was just looking to see if we can reduce it somewhere else, but we'll just keep it like this. This will be fine. So what is that? 57 over 60. Always check to see if your fraction is reduced. Is this reduced? No, it's not. So any idea what goes into both of those? 3 goes into both of them, right? How do I know 57? 57 is not one of those numbers that just pops in my head, is it? Okay. How do you figure out now, does 2 go into 57? No, because it's an odd number, okay? Try 3. How do you know if 3 goes into a number or something, or divides into a number evenly? Brooklyn? The digits? Yeah. Exactly, okay? So if you add them up, 5 and 7 is 12. Does 3 divide into 12? Yeah, absolutely. So that means 3 divides into 57, all right? And you can just do the work on that. 3 goes into 57 19 times, and 3 goes into 60. You can do that in your head, can't you? And that's 20, and that would be your answer right there. We good with that? All right, so now I'm officially finished section R1, and I'm going to stop my recording.